Calculus. Maximum and minimum problems. From a 30 centimeters by 30 centimeters sheet of cardboard, square corners are cut out so that the sides are folded up to make a box. Part 1, what dimensions will yield a box of maximum volume? Part 2, what is the maximum volume of the box? It's a good idea to draw out a picture of what this would look like. And very important to note that if the sheet of cardboard is 30 by 30 centimeters, that means the length and the width are both the same, then that the sheet of cardboard is a square sheet of cardboard. And it's also important to note that square corners are cut out so that the sides are folded up to make a box. So that's very important that it is square corners. So again, square corners are going to have a length and a width that are the same. So let's draw out this picture. So if we start off by drawing a large square, 30 centimeters by 30 centimeters. Now obviously if you're drawing this as a rough sketch in your copy or in an exam paper, it doesn't have to be exactly 30 centimeters, but it is important that it is a square. So we can start off with a large square. And we're going to label the length as 30 centimeters, and we're going to label the width as 30 centimeters. So this is our sheet of cardboard. Now we know that square corners have been cut out. So we're going to cut out a square corner from each of the four corners. And we're going to label the length and the width of each of those squares as X. We don't know what the length or the width is, but we do know that they are the same because it's square corners. So we're going to label them all as X. Now the idea is that we will fold this side up, and we'll fold this side upwards, and we will fold the top upwards and the bottom upwards as well, so that we can create a box. And if we do that, we should end up getting a three-dimensional shape that looks like this. So our length and our width of our box are both going to be the same thing, but we need to come up with an equation that represents the length and the width. So if we know that this entire length is 30 centimeters, and we're missing this part which we've labelled as X, and we're also missing this part which we've labelled as X, it's going to be 30 minus X, which is going to be 30 minus 2X for this part here. So this is going to be 30 minus 2X. And likewise, if we know that this entire length here is 30, and we know that this is X, and this is X, and we're missing both of those bits, then this part here is going to be 30 minus X, which is 30 minus 2X, which is obviously the same. So the length and the width are the same, and we're going to call that 30 minus 2X and 30 minus 2X. Now we know that if we were to fold along this line here, and bring this part upwards and do the same on the other side, and here, then the X part is going to join up, this X length will join up with this X length, and this will actually be the height of the box. So this section here represents the top of the box, and this section here represents the bottom of the box, which we found to be 30 minus 2X. This section here ends up to be the top of the box, and this section here ends up to be the bottom of the box, which represents 30 minus 2X. And then these two parts go together, giving us the X, so the height of X. So obviously this is going to be a height of X, this is going to be a height of X, this is going to be a height of X, and this is also going to be a height of X. This is a length of 30 minus 2X. This is a width of 30 minus 2X. Along the back we also have 30 minus 2X and 30 minus 2X. And then along the top, 30 minus 2X, 30 minus 2X, 30 minus 2X, and 30 minus 2X. So they are the dimensions of the box. So we're interested in what dimensions will yield a box of maximum volume. So we found the side length to be 30 minus 2X, and we found the height to be x. So 30 minus 2x and a height of x. Now, the volume of a cube or a cuboid is the length times the width times the height. This formula is not given to you in the formula tables in the leave insert, so it's going to have to be learnt off by heart. So the volume of a cube or a cuboid is length times width times height. So we know that the length is 30 minus 2x, the width is 30 minus 2x, and the height is x. So it's going to be 30 minus 2x multiplied by 30 minus 2x multiplied by x. So that's where this comes from here. 30 minus 2x multiplied by 30 minus 2x multiplied by x. So if we just start off by multiplying out 30 minus 2x and 30 minus 2x. 30 by 30 is 900. 30 by minus 2x is minus 60x. Minus 2x by 30 is minus 60x. Put them together to get minus 120x. And minus 2x by minus 2x is plus 4x squared. We must remember to bring down the x with brackets around it because we're going to have to multiply across by the x as well. So 900 by x is 900x. Minus 120x by x is minus 120x squared. And 4x squared by x is going to be 4x cubed. So this is an equation for the volume of our cube. So we're interested in the maximum volume. And when we hear the word maximum or minimum, we want to think differentiate. So we're going to get the derivative. So we're going to differentiate v with respect to x. So dv dx means we differentiate v, this is v, with respect to x. So if I want to differentiate 900x, I simply just cross out the x. If I want to differentiate minus 120x squared, I bring the 2 down in front, multiply it by 120 to give me minus 240, and then I reduce the power by 1, so I get to x. And then 4x cubed, I bring the 3 down in front, 3 by 4 is 12, reduce the power by 1, 3 take away 1 is 2, so I get 12x squared. So I was asked what dimensions will yield a box of maximum volume. The first thing I had to do was multiply the length by the width by the height to get the volume. And I got a volume of 900x minus 120x squared plus 4x cubed. And because I'm interested in the maximum volume, I had to differentiate. dv dx would give me 900 minus 240x plus 12x squared. So now what I'm going to do is let the derivative be equal to 0 so that I can find my stationary points. So I'm going to need to solve. So I let the derivative 900 minus 240x plus 12x squared be equal to 0. And then I'm going to solve so that I can find my stationary points. Now, before I solve, I'm going to just simplify this as much as I can. So I'm going to think, well, what will divide into 900, 240 and 12? And that's going to be 3. So I'm going to divide across by 3. And I'm also going to start off with my x squared term. So 12x squared divided by 3 is going to give me 4x squared. And I'm going to put that in front because I like to have my x squared term in front. So 12x squared divided by 3 is going to be 4x squared. Next, I'm going to have my x term. So minus 240x divided by 3 is going to give me minus 80x. So I bring that down here. And then last, I have my constant. So 900 divided by 3 is going to give me 300. So I bring that down here. So 12x squared divided by 3 is 4x squared. Minus 240x divided by 3 is minus 80x. And 900 divided by 3 is 300. Still equal to 0. Now, I notice that I can still divide across, and I can actually divide by 4. So 4 divided by 4 is going to be 1. So I'm going to have 1x squared, or just x squared. Minus 80 divided by 4 is going to be minus 20, giving me minus 20x. And 300 divided by 4 is going to give me 75. So I simplify even further, getting x squared minus 20x plus 75. Now, what I could have done initially was just divide it across by 12, but if you didn't notice that 12 was the highest common factor of the 3 terms, you could have started off with 3 and then used 4, or vice versa, started off with 4 and then divided by 3. Either way, you're still going to get to x squared minus 20x plus 75 is equal to 0. At this point, I'm going to factorize and then I'm going to solve. So factoring x squared minus 20x plus plus 75. It's going to give me x minus 15 times x minus 5. The x squared lets me bring an x down in the front of each bracket. This being a positive tells me the signs are the same. This being a negative tells me they're both negative. I need to get the factors of 75. That will add or subtract together to give minus 20. I'm going to go with 15 and 5. 15 times 5 is 75, but minus 15 minus 5 is minus 20. So these are my factors. I'm going to let each of them equal to 0, so x minus 15 equals 0, so x is equal to positive 15, and x minus 5 is equal to 0, so x is equal to positive 5. I now have solved my equation, and I have x values of 15 and x. Alternatively, to solve a quadratic, I could have used the quadratic formula or the minus b formula. Now remember, I was asked to find the maximum volume. So what I have to do next is find the second derivative. So d squared v dx squared is going to give me minus 240 plus 24x. So where did I get that from? Well, if I go back to my derivative that I just got a minute ago, 900 minus 240x plus 12x squared, I'm going to get the second derivative. So I've got 900 there as my first term, and that's a constant, so cannot be differentiated. So I can just cancel that out. Then I have minus 240x, so I can just cancel out the x term. And then I have 12x squared. I'm going to bring the 2 down in front. 2 by 12 is going to be 24. And I'm going to subtract 1 from the power. 2 take away 1 is 1. So I differentiated 900 minus 240x plus 12x squared. And I got the second derivative to be minus 240 plus 24x. So my two x values I got were 15 and 5, so I'm going to sub both of those into the second derivative, and I'm going to figure out my local maximum and my local minimum. So if x is equal to 15, subbing into my second derivative, which was minus 240 plus 24x, I'm going to swap the x for 15, so it's going to be minus 240 plus 24 multiplied by 15, which is 360. So minus 240 plus 360 is going to be 120, and 120 is greater than 0. Therefore, there is a local minimum at x is equal to 15, because we worked out 120 was greater than 0, so therefore we have a local minimum at x is equal to 15. If this had ended up to be less than 0, we would have had a local maximum at x is equal to 15. But since 120 is greater than 0, we have a local minimum at x is equal to 15. So now what we need to do is sub in the 5 in the same way.